Hello to everyone. Well, welcome back to mechanics. We are doing vertical projectile motion. We are going to have about how many videos? 1, 2, 3, 4, 5, 6. About 6 videos here. It's an introduction. Then we sketch the graphs. Okay. Of an object which is thrown vertical upwards. Alright, then of an object that is thrown vertical downwards for a bouncing object, then we interpret. So we have about how many? 1, 2, 3, 4, 5 videos here. Alright, let's quickly go straight to the definitions of a vertical projectile motion. We have a projectile. As you can see, vertical projectile motion, we have a projectile. The projectile is an object which has been given an initial velocity, and then it moves under the influence of gravitational force only. So every term here is very important. Once you miss, for example, you miss this only, then you get 0 out of 2, right? So the projectile is an object that is given an initial velocity, and then it moves under the influence of gravitational force only, which means if you are drawing a free body diagram of a projectile, let's say you have a ball that is thrown vertical upwards, then they say draw a free body diagram. Remember, the free body diagram will show all the forces. So we have the bullet that will represent the ball. Then they say this object is given an initial velocity and it moves under the influence of gravity only, which means we will have only the gravity. Okay, let me try to draw a vertical line. So you will have what? A gravity, that is a weight or a gravitational force on your free body diagram, because it says it moves under the influence of gravity only. Remember that if the object is moving under the influence of gravity, it is attracted towards the center of Earth. So as it moves down, the speed is increasing, which means the object is accelerating. Then since we have only one force here, that will simply mean, if we can look at Newton's second law, F net is equal to ma. So we have only one force here, which is the weight, that is Fg is equal to ma. And remember, Fg is a weight, is calculated by mg. So mg is equal to ma. So if we divide by m both sides, we have a, which is equal to g. Since we have only one force, therefore the acceleration is constant, is 9.8, is g, that is 9.8 meters per square second, always downwards, because it is a vector quantity. Okay, then we have another definition of a free fall. Free fall is the motion during which the only force acting on an object is gravitational force. Even in this definition, we have that only, the only force, which means the free body diagram is the same. So we have the projectile, that is the projectile, right? Then we have the motion, projectile motion, that is the free fall. Projectile motion, free fall, that is the projectile motion. Free fall is the motion, right, during which the only force acting on an object is gravity, or gravitational force. So that is the definitions of free fall and a projectile. And don't forget that we also have the we also have the the acceleration, which is always constant here. The acceleration is g, which is 9.8 downwards. So this is also important, right? Now let's continue with our projectile motion. Now what we are going to do is to come with an example of a projectile. That is an object that is given an initial velocity and then it moves under the influence of gravitational force only. So let's say we have the object that is thrown vertical upwards. Let's say this is the thrower's hand. Then this ball is thrown vertically upwards. This is the ball that is moving upwards. It reaches the maximum point and then it turns back to the thrower's hand. It turns back to the thrower's hand. Now this ball is having the initial velocity, that is the initial velocity here. Let's just give it an initial velocity which is 10, and this initial velocity is moving upwards. So what we need to know is that when it reaches the thrower's hand, it will still be moving with that velocity which is 10, which means the velocity here will also be equal to 10 when it reaches the thrower's hand, but it's 10 downwards in this case, the velocity here. Then here there is a maximum point here, the maximum point. So you will remember that the maximum point is a turning point in mathematics, which means here the velocity here is equal to 0. At a maximum point, the velocity is always equal to 0 meters per second. At a maximum point, you must know that the velocity is equal to 0 meters per second, maximum point, right? So another thing that you need to know is that this object is accelerating because there is a change in speed here. Remember, it was moving at 10 here, which means 8, 7, 6 up until it gets to the maximum point where it will be having a 0 velocity, that is 0 meters per second. So it is changing the speed over time. There is a change in speed over time, meaning that there is an acceleration here. Okay, let me draw it to be bigger so that I will write everything, at least this one. So I said the velocity here is equal to 0 or is equal to 10 upwards. Then the velocity when it reaches the same point, it will be what? 0, but in the 10, but in this case is moving downwards. Then here this is the maximum point. Once you see the term maximum, you must know that the velocity there is equal to 0 meters per second, right? Then if you can see here in this path, let's say this is point A, this is point B, this is point C. In this path AB, the speed changed from 10 to 0. From B, C changed from 0 to 10, which means there is a rate of change in velocity here, that is acceleration. So the acceleration, we said it is constant. The acceleration is constant, which means here the acceleration is 9,8 meters per square second, and this acceleration is always downwards. Even here the acceleration is 9.8 meters per square second and is downwards. Even here when the velocity is 0 here, the acceleration is still that 9.8 meters per square second downwards. Even here the acceleration is still, because we say it is constant, meters per square second downwards, even here up until it is not moving, right? Okay, now what can be asked here is to calculate the time it takes to reach the maximum point, or the time it takes to reach position C, that is to come back to the thrower's hand. Okay, so we are about to calculate the what we can, in fact we are going to calculate the time, right? Then you can also calculate the position of the ball after a certain time, or the height, the maximum height. So we can calculate the position. Okay, then you can calculate the velocity or the speed at a certain position. Okay, that is, the position is represented by x. Then it will depend what we are calculating. Now before we calculate this, we need to know that the speed, the time taken from A to B is the same as time taken from B to C. So it is symmetrical from the thrower's hand to the thrower's hand. So the time from AB is the same as the time from BC. The distance from AB is the same as distance from BC, right? I think that is clear. Okay, now what we are going to use when we calculate the time, the velocity, the position is the equation of motion that you have studied from grade 10. Equation of motion. So we have about 4 equations of motion. Then we have number 1. I have my number 1, that is the final velocity is equal to the initial velocity plus a delta t. Then we have number 2, which is final velocity square, which is equal to initial velocity square plus 2a delta y. We have number 3, which is delta y, which is equal to the initial velocity delta t plus 1 over 2 a delta t squared. Then we have 4th equation, that is delta y is equal to initial velocity plus final velocity over 2 times everything is multiplied by delta t. Okay, so this one is, these are the equation of motion. We are going to use them to calculate the velocities, that is initial velocity, final velocity, we know acceleration, delta t. We are going to use them to calculate the final velocity, initial velocity, we know the acceleration, delta y is the position, is the height, is the displacement, is the distance, right? Then we are going to use this equation of motion. Now what is important is to collect the data before we calculate whatever. So we need to collect the data. Okay, now let's go to, let's start with the time from A to B. Let's start with the time from A to B, from B to C, from A to C, right? We are going to calculate the time. Okay, so remember we have the object that is moving up, vertically upwards, that is 1D, and it reaches the thrower's hands. This is A, this is B, this is C. So the velocity here is 10. That is what is given. The initial velocity is 10 meters upwards. Then we know that here is the turning point, that is the maximum point. The velocity will always be equal to 0 at the maximum point. Okay, now the question says calculate the time it takes to reach the maximum height. Calculate the time, calculate the time the ball takes to reach the maximum point. That is the first question that we have. So which means we are looking for the time from A to B in this case. So we need to collect the data, then we go to the equation of motion. We choose the one that have the data. Okay, what we are looking for, that is the first thing that you need to write on your data. We are looking for time from A to B. Okay, what do we have? We have the initial velocity. We are given the initial velocity, that is 0 or 10, I mean, then is 10 upwards. What else do we have? That the term on the question maximum point tells us the velocity is equal to 0, which means in this case it's our final velocity. What else do we have? Is the acceleration. We know that the acceleration is constant, is 9,8, but downwards, right? So this is the data that we have. Then you go to the formula sheet and check which formula goes with this data. Let's go back to the formulas. So we have the final velocity, initial velocity, acceleration. We're looking for time. So equation number 1 is perfect for our data. Okay, equation number 1. So final velocity is equal to initial velocity plus a delta t. Now, since we are talking about vectors here, we need to choose the direction. Remember, we have the arrow that is pointed up and the arrow that is pointed down, which means we need to choose the direction. Let's take upwards as positive. Upwards must be positive in our case. So upwards is positive, which means this 10 is positive, but this 9.8 is negative. Now we can substitute. So the final velocity is 0. The initial velocity is positive 10 plus the acceleration is negative 9,8 delta t. So we are going to transpose 10 to that side. So we have 10, which is negative, which is equal to negative 9,8 delta t. Then we divide by negative 9,8 both sides. So we have delta t, which is equal to, then we press the calculator. Then we get the time, which is 1,02 from A to B. So we know the time from A to B. From A to B, the time is 1,02 seconds, which means from B to A to C is also that 1,02 seconds, right? Which means so the time it takes for the ball to come back to the thrower's hand, that is delta t from A to C, is equal to 1,02 plus another 1,02. Then we get 2,04 seconds. We can also calculate it. Let's do it. Let's collect the data. We are given that the initial velocity is 10 upwards, right? Then we have the final velocity. Remember, now we are looking for time from A to C, which means the initial velocity is the velocity at A, then the final velocity, the velocity at C. Okay, let's go back to the diagram. We said since it is moving at 10 meters per second here upwards, when it reaches the same point, the velocity here will also be 10 meters but downwards. Okay, so let's go. The data will be like, we have the final velocity, which is 10 also but downwards. Then we have acceleration due to gravity, which is 9,8 downwards. Then we choose the direction. We said upwards is positive, this one is positive, then this one is downward, therefore it will be negative. This one is downward, which means it will be negative. So we are going to use the same formula because we have final velocity and initial velocity, time and acceleration. So final velocity is equal to the initial velocity plus a delta t. Now let's substitute. The final velocity is minus 10. The initial velocity is positive 10. The acceleration is 9,8 delta t. Delta t is between A and C. So we are going to transpose that 10. Then figure the negative part. Then we have negative 20, which is equal to negative 9,8 delta t between A and C. Then we divide by negative 9,8. Negative 9,8. Then we get delta t, which is equal to, then we say 20 divided by negative 9,8. We get 2,04 seconds. Then we're done. So this is another way to calculate it, or you can just calculate one side, then you just say times 2. Okay, then another question that can be asked here is the maximum height. Okay, maximum height. Remember, the object moved up, then comes to the thrower's hand. So we said the initial velocity here is 10 upwards. So at maximum point, the velocity is equal to 0. This is what was given. Then the question says calculate the maximum height, which means the height from the thrower's hand to the maximum point. That is the height. Now, when you calculate the height, okay, let me write the question. Question number 2, determine the maximum height, that is h in this case. So because of maximum, we know that the final velocity is equal to 0. Final velocity is equal to 0. Then the height on the equation of motion is represented by dy. The height is what we're looking for. Then the initial velocity is 10 upwards. So this is what we have. Then we always know that the acceleration is always there, that is 9,8 downwards. Okay, so we choose the direction. We said take up as positive, which means this one is positive, this one is negative. Then we calculate the height. Remember, the height is a scalar quantity. Okay, the velocity is a vector quantity. The time is a scalar quantity. So since the question says calculate the height, which means you have to leave your answer positive, but there is no direction because we're talking about the height. Okay, now the formula that goes with this data, final velocity, initial velocity, dya, is, let's check, that is supposed to be equation number 2. of our equation. So we have final velocity, initial velocity A, and delta y. So we're going to use that one, maximum height. So final velocity is equal to its final velocity square is equal to initial velocity square plus 2a delta y. This is the formula that we're supposed to use. Okay, final velocity square, initial velocity square plus 2a delta y. Okay, so let's substitute. The final velocity is 0 because of that maximum. The initial velocity is positive 10. The acceleration is negative 9,8. Oh, there's that too. We have this 2 of the formula 2 into negative 9,8. Then we are looking for delta y, which represents the height in this case. So 10 squared is 100. Then we transpose 100. It's negative 100, which is equal to negative 2 times 9.8 is 19.6 delta y. Then we divide by 19.6. Then we divide by negative 19,6. Negative 19,6 both sides. Then we get the maximum, or get dy first. So we get dy, which is equal to, let's press calculator, that is 5,10 meters. We are not calculating the displacement, we are looking for the height. Therefore the height, the maximum height is 5,10 meters. Then we are done with the height. Then another question that can be asked here is to calculate the distance traveled by the object. So in our case, traveled by the ball. So the distance, you remember we said we have A here, we have B here, we have C here. So the distance traveled is A, B, C. Okay, which means to calculate the distance, you have to add the distance of AB and the distance of BC. That is the distance. So the distance that is traveled by the ball, distance. Remember, the distance is a scalar quantity, so you just add. We know that the height is 5,1, meaning that 10 meters, meaning that the distance from AB is that 5,1, and also the distance here is 5,1 meters. So we just add that to get the distance, which is 5,10 plus another 5,10. Then we get 10,20 meters. That is the distance. Then if they ask for the displacement of the ball from A to C, remember now we're talking about the displacement. So displacement is delta y. That is the displacement, which means we have to choose the direction, take up as positive. So this one will be positive, then this one is negative, so you combine them. So we have 5,10 plus minus 5,10. Therefore the displacement from A to C is 0 meters. There's a difference between displacement and the distance. The distance, no direction is chosen, just add plus plus. Then the displacement, you have to choose direction, take up as positive, which means down is negative. Okay. Now let's go to another type of question that can be asked here, where the object is thrown from a certain height. Okay, from a certain height. Now let's look at this one. We have the initial velocity the same as that one, that is 10 meters upwards. Then we have the height of the building, which is 50 meters, 50 meters high. Then we know the acceleration is always that 9.8. Now the question is calculate number one, calculate the maximum height again. So if the question says calculate the maximum height reached by the ball, then because of that maximum, so we know that the velocity there is equal to 0. So we have the initial velocity is equal to 10, but upwards. Then we are looking for height. The height is calculated by dy. We are looking for dy. Then a is the acceleration, which is 9.8 downwards. Then we took up as positive, so this one is positive, but this one is negative. So which equation we are going to use? If we have this equation number 2, so equation number 2 was a final velocity square is equal to initial velocity square plus 2a delta y. Okay, then the final velocity here is 0. We have 0 squared, which is equal, the initial velocity is 10. Then we have 10 square plus 2 into negative 9.8 delta y. Then 10 is 100, then you convert, or 10 squared is 100, then you transpose. So we have minus 10, or 100 I mean, which is equal to minus 2 times 9.8, it's 19.6 dy. Then we divide by negative 19.6, both sides negative 19.6. Therefore dy is equal to 5.10 meters, which means from here to here, because we use the velocity which is equal to 0, this is 5.10 meters. But the maximum height is from here down here, which means the height here that we are talking about will be that 50 plus this 5.10, then we get 55.10 meters. Okay, then another question that can be asked, calculate the velocity, that is number 2 of this one. Number 2, calculate the velocity. Calculate a velocity of the ball when it reaches the ground. Okay, so we are looking for the velocity at C. This is very easy. Now what we are going to do, since we are talking about the velocity, we have the initial velocity here, then we are looking for velocity here. We have the distance from here to here, that is 50 plus 5.1, so we can use that one. Okay, but what is given on the statement? We are given the initial velocity straight down, and what? And the displacement or height. Okay, we are not interested by this side, right? From here to here is 50, and this 50 is below, which means go downwards, right? So this is the easiest way. So let's collect the data. So we have what? The initial velocity that was given, which is 10 upwards. Then we are looking for the final velocity, that is the velocity at C. Okay, we have delta y, that is our height there, which is 50, and this 50 is below the starting point, which means go downwards. Okay, we also know the acceleration, that is 9,8, always downwards. Don't forget that when you are collecting data, you must have 4 quantities. So we have 1, 2, 3, 4. So you must have 4. Then you go to the formula sheet and choose the one with these 4 quantities. Okay, now which formula is this? The same formula, this one. Okay, so we are going to use the final velocity square, which is equal to the initial velocity square, plus 2a delta y. The final velocity is what we are looking for. The initial velocity is 10 square, which is positive, plus, okay, plus 2. Remember, we forget to put the direction. We said up is positive, which means this one is positive, this one is down, negative, this one is negative, down. Okay, so we have negative 9,8 here, then here we have negative 50. Then we press calculator to get VF square. So we get 10.8, then sifake square root both sides, so it's plus or minus. So the final velocity will be equal to 32,86 plus or minus. Since it is going down, that is negative, because we take upward as positive. So we choose negative between low plus and low minus. So the final velocity is equal to 32,86 meters per second. This negative tells us is going downwards, then downwards, downwards. Then we are done with this one. Now let's go to another example. So in this case, there is the object that is moving up with constant speed. It drops something downwards. So that is the example we are going to do now. So let's say we have the hot air balloon. That is moving with constant velocity, let's say 5 meters per second upwards. Then it drops, let's say the cell phone, it drops the cell phone at 10 meters above the ground, right? So the question that can be asked here is the velocity, the final velocity of the ball, of the camera, or what is it, of the cell phone, when it reached the ground. This is the ground. So this is very easy. Since this one is moving with constant speed, because of that constant speed, the hot air balloon only is having acceleration which is 0 meters per square second. But this one, if they say ignore the effect of air resistance, this one is on free fall. So the cell phone is on free fall, meaning that the cell phone is having the acceleration which is 9.8 meters per square second downwards. So senze shoba sizibhidanisa izinto, so we have the hot air balloon and the cell phone. The cell phone is on free fall, but the hot air balloon is moving at constant speed. Constant speed or velocity. So since it is moving with a constant speed, the acceleration is 0 meters. There is no change in 0 meters per square second. There is no change in speed. So the focus is on the camera now, which is on free fall. So there is no problem. We are going to collect the data where we have it was moving with this speed initial. So the initial velocity of the cell phone is the velocity of the hot air balloon. Okay, then we are looking for the final velocity. We have this 10 meters which is delta y, and this 10 meters is below the starting point, which means is below downwards. So we have the acceleration. The acceleration of the cell phone which is on free fall is 9.8 meters per square second downwards. Then we choose the direction. So up is positive, down is negative. Then we calculate the final velocity. So we are going to use formula number 2 in this case, which says final velocity square is equal to the initial velocity square plus 2a delta y. So we are looking for the final velocity, which is equal, the initial velocity is 5 in this case, square and is positive, plus 2 negative 9.8 acceleration, dy is negative 10. Then we press the calculator to get Vf square. Then we get 221, then we apply the square root. Then we have plus or minus square root of this one. So the square root of that one is equal to, the final velocity is equal to negative 14.87 meters per square second. Since it is negative, so that is downwards, 14.87 meters per square second per square downwards. Then we're done. That is it. So we must know that there are two. But if they say calculate the, for example, they say calculate the weight of this hot air balloon. So you need to draw a free body diagram. There is the upward force that causes the object to move up, that is applied force. Then we have the weight here, that is Fg. So we have two forces. So F net is equal to Ma. So we have take up as positive minus Fg, which is equal to Ma. And remember that acceleration is 0, which means everything is 0 there. Then you can calculate, you will be given the force applied. Why there are two forces? This one is not on free fall. Acceleration is not equal to 9.8. But the cell phone is on free fall, which means we have only one force, that is what? Fg. That is the vertical projectile motion. That is the vertical projectile motion. So the following video is on sketching the graphs. We are going to use the same examples, that is the first one and this one, to sketch the graph. Okay, we are going to do another example of an object that is bouncing. Then we sketch the graph. Thank you. Don't forget to subscribe. Thank you.